In this video, I wanted to show a really cool Bayes Theorem problem. Let's read it. Reese's Pieces come in three colors, orange, yellow, and brown. The color of each individual piece is uniformly distributed between these three colors and is independent of all the other colors. All right, so with M&Ms, there's six colors, orange, yellow, brown, blue, red, and green. The color of each M&M is uniformly distributed between six colors and is independent of all other colors. You have 4 large bags of Reese's Pieces and 8 large bags of M&Ms in your pantry. You grab one of the 12 packs at random, but don't trouble yourself to look at the label. You start picking out and eating the candies one by one. Suppose you eat an orange candy, then a yellow candy. What's the probability that you're holding a bag of Reese's Pieces? So this is a really cool problem. The probability that we're trying to solve here is the probability that we're holding a bag of Reese's given we pick orange and then we pick yellow. All right, so let's go ahead and see if we can write the numerator here. That's going to be the probability of orange then yellow given we're holding a bag of Reese's times the probability we have a bag of Reese's. And then in the denominator, we need to solve P of OY, the probability of orange yellow, and here we need to use the law of total probability, which states that if we add up the probabilities like this, the probability, say, orange y, given Reese's times the probability of Reese's, but we also have to add the probability P orange y yellow given it's an M&M bag times the probability of M&M bag, because there's two different events where we can get orange yellow. Okay, so let's go ahead and substitute this in. So we have the probability of Reese's given orange yellow is equal to the probability of orange yellow given Reese's times the probability of Reese's over the probability of orange yellow given Reese's times the probability of Reese's plus the probability of orange yellow given M&Ms times the probability of M&Ms. So the numerator here, what's the probability that we pick orange and then we pick yellow given it's Reese's? Well, since there's 3 colors to choose from and it's uniformly distributed and independent of all the other colors, we have 1/3 times 1/3 as our probability there. And then we need the probability of picking a bag of Reese's in the first place. And since there's 4 bags of Reese's out of the 12 packs, we have 4 over 12 here. So that's the first bit for the numerator. And in the denominator, we're going to have that same thing. But we're also going to add the probability of orange yellow given M&Ms and multiply that by the probability of M&Ms. So since there's 6 to choose from and it's uniformly distributed, we have 1/6 times 1/6, and it's also independent. We also need to multiply by the probability of picking M&Ms in the first place. And since there's 8 bags here, 8 bags of M&Ms out of the 12, it's going to be 8 over 12 here. And doing a little simplification in the numerator here, we have 1/3 times 1/3, which is 1/9, and then times 4 over 12, which is the same thing as 1/3. So we have 1/9 times 1/3, which is 1 over 27. Over here, we have the same thing, so 1 over 27 here. And then plus 1/6 times 1/6, which is 1 over 36, times 8 over 12, which is the same thing as 4 over 6, right? And if we keep simplifying this, we have 1 over 27 over 1 over 27 plus this 4 and this 36, make it 1/9 times 1/6. So this is equal to 1 over 27 over 1 over 27 plus 1 over 54. All right. And if we change everything to have the same denominator of 54, we have 2 over 54 over 2 over 54 plus 1 over 54. And if we bring this 54 down, since it's in the denominator of the numerator, we get 2 over 2 plus 1, which is equal to 2/3. So what we found here is, even though we only have 4 bags of Reese's Pieces, if we pull an orange candy than a yellow candy, we have a greater likelihood of having Reese's Pieces. And this sort of intuitively makes sense because Reese's Pieces bags only contain 3 colors, orange, yellow, and brown. So if we're pulling orange and yellow, the odds we're taking from a Reese's Pieces bag are a little bit higher than if we're taking from an M&Ms bag, since the M&Ms bag contains 6 colors. So this is a kind of cool result and a nice application of Bayes. So I hope you enjoyed this video and have a wonderful day.